Hey, today we're going to use what we learned to solve quadratic equations. We've factorized simple expressions, quadratic expressions. Today we're going to have quadratic equations, and we're going to solve for x using factorization. Okay, remember quadratic expressions. A quadratic expression has this form. A, B, and C are numbers. A cannot be 0 because then the x squared would be gone. It would no longer be quadratic, right? Today we're looking at quadratic equations. A quadratic equation is really a quadratic expression where A, B, and C are numbers and A is not allowed to be a 0, just like here. But a quadratic equation is a quadratic expression that we've set equal to 0. And I say 0, or the form that we like has it equal to 0. We could also set it equal to a number, but we would then rearrange the equation so that we have 0 on this side. I will show you how to do all of that. I want you to first look quickly at this example. Say this is a parking space or some kind of field or pavement in the backyard. Say that this is the height and this is the width. If it's a field, it's going to be width and length and no height. But all right. If we want to express the area of this field, we're going to say field, then we would multiply this times that. Length times width is the area of this field, right? And if we expand, we would get this, right? Plus 2x minus 3x is minus x, plus 2 times negative 3 is minus 6. Yes, this is a quadratic expression for the area of the field. Okay? Now, what we're doing when we're setting a quadratic equation equal to 0 or another number is we then turn it into a quadratic equation. And with our field, that would be like, you can see that this x is unknown. Let's say we want the area of this field to be 24 squared meters. We're now saying we want this to equal 24. So can I just write that here? I want this quadratic expression for the area of this field, I want it to be equal to 24. Yeah? We have an equal sign. We've set it equal to a number. We now have a quadratic equation. And as you can see here, we want it to be set equal to 0. That just means I have to reorganize some stuff to get 0 on one side. And you notice how that is really easy. We combine that with the c value here. So we subtract 24 from both sides. Negative 6 minus 24 is negative 30. And here 24 minus 24 is 0. Now, this is also a quadratic equation, but this is the quadratic equation, the same one, but in the form that we like it in, set equal to 0. Because from this point, we can start solving it to find the value for x that would make this true. So by using factorization to solve this quadratic equation, we can find the x value and we can find the exact length and width of the field that would make it have an area of 24 square meters. Okay? Before we can start solving equations like this, we need to get one thing straight. This is what it's all based on. Super logical. If A times B equals 0, then what does that tell us about A or B? How are we going to get a product of 0? We can only get that if one of the factors is 0, right? When we multiply things, the answer is 0 if one of those two things is 0. So either A is equal to 0 or B is equal to 0. Yeah? Seems super obvious, and it's what this whole solving business is based on. Oh, nice one. I have 4 examples of quadratic equations that we're going to solve. I just want you to understand the process for now, to kind of see the steps in solving it. I don't need you to fully understand how it relates to actual situations with fields and stuff. We will get back to this type of problem in the next lesson. So I just want you to understand the process for now. Like we said, we want it to be set equal to 0. That's already there for us in this one. This one is not equal to 0 yet, so I'm going to restructure it so that it's in the form that we like it in, right? Subtract 10x from both sides. Here, I have to change it like this, so it's equal to 0, and this one's already equal to 0. So now I'm ready to start solving these. And like the title said, we're going to use factorization to solve these. So let's factorize this. We can pull out an x. The highest common factor here is x. Yes? This times this is equal to 0. That means that either this x is equal to 0, or x minus 3 is equal to 0. If x minus 3 is equal to 0, then x is equal to 3. So our answer would be x is equal to 0 or x is equal to 3. Yeah? Let's do this one. We're going to factorize this. There's a common factor of x, so x, and I'm looking here, right, times x minus 10 is equal to 0. That means that either x is equal to 0 or this factor, x minus 10, is equal to 0. I put the parentheses just so you recognize it from up there. We don't actually need the parentheses here, right? If this is equal to 0, then x equals 10. The proper way you would write your answer is like that, and then put a box around it. You need the word or. Here we have the difference between squares. So when we factorize this, we get x plus 5, because 5 is the square root of 25, and x is the square root of x squared. Remember how we did these? That means either x plus 5 is equal to 0, or this one, x minus 5, is equal to 0. Right? Either this factor or that factor is equal to 0. If this factor is equal to 0, then x equals negative 5, right? If this factor is equal to 0, then x is equal to positive 5. That's our answer. This one, let's factorize x. The factors of 6 are 1 and 6. 1 times 6, 2 times 3, and -1 times -6, -2 times -3. Which combination of factors adds up to -5? This one does. So I'm going to put x minus 2 times x minus 3, right, is equal to 0. That means that either this factor or this factor is equal to 0. X minus 2 is equal to 0, or x minus 3 is equal to 0. That means that x equals 2 or x equals 3. And that is our answer. Let's just try some of these, and then in the next lesson we'll put them more into context and think more about what we're actually doing. This is the process. Let's practice with that first.